In this video, we are going to solve a quadratic equation, which is reviewing what we learned from grade 10 when you worked on quadratics. So hopefully you remember some of the ideas that we're going to talk about today. Okay, so before we solve a quadratic equation, I just want to highlight the difference between solving a linear equation and solving a quadratic equation. So if you're solving a linear equation, all you have to do is perform inverse operations, and then you'll eventually isolate for x. So for example, subtract both sides by 4 here, divide both sides by 3, and bam, there you go. That's it. Now, unfortunately for a quadratic equation, you can't really perform inverse operations to isolate for x. So you need to develop some new strategies. So what are these new strategies? Well, here you go. So you can factor, as long as it's factorable over rational numbers. You can use a quadratic formula. That's always an option, but unfortunately the quadratic formula is a little slow. You can solve by completing the square, but once again it's a little slow. Now if you know the quadratic formula, there's really no need to solve by completing the square, because the quadratic formula is basically like a shortcut for this technique. But anyways, if you forget the quadratic formula, then by all means go ahead and solve by completing the square. Now as for technology, there are a lot of different ways. There are calculators that can solve a quadratic equation. You can use a graphing calculator to graph the parabola and then try to solve the equation that way. So yeah, there's a lot of different ways if you're gonna approach it using technology, but it's really unnecessary. Like for a quadratic equation, you don't need it. Okay, so those are the techniques, but I will predominantly focus on factoring and using the quadratic formula. So my go-to strategy for solving a quadratic equation is first try to solve it by factoring. If it's not factorable over the rational numbers, then I'm going to use a quadratic formula. All right, here we go. So can I factor? Are there two numbers that multiply negative 24 and add to negative 4? Let's see. Negative, ooh, wait a second. Hold on here. 8 and 3 doesn't work. 6 and 4 doesn't work. Oh, wait a minute. It's not factorable. So if that's the case, then I guess we have to use a quadratic formula. It's unfortunate, but it is what it is. So negative b plus or minus b squared minus 4ac all over 2a. And I'm going to keep the roots as exact answers. Now, in grade 10, you didn't learn how to simplify radicals, or maybe you did, but I would argue most of you didn't. So now that we know how to simplify radicals, 112. Ooh, 112 has a perfect square factor of 16. So if that's the case, I can simplify this a little. So this is root 16 times root 7, which is 4 root 7. And divide everything by 2, so that's 2 plus or minus 2 root 7. Beautiful. Now that you can work with radicals, or you have a better handle simplifying radicals, then you can definitely make these answers a little more simplified. Okay, x squared minus 5x minus 2 equals 0. Well, that's definitely not factorable. So unfortunately, that means I have to use the quadratic formula again. It's okay. Good practice, since you probably haven't touched this since grade 10. Negative b plus or minus square root of b squared minus 4ac all over 2a. So the discriminant here ends up being 25 plus 8, which is 33. And 33 as a radicand, I can't simplify that because 33 has no perfect square factor that's greater than 1. So yeah, 33 is 11 and 30, 11 and 3, and 33 and 1. So yep, that's it. Can't do anything. Okay, now if you look at the left side here, it's basically vertex form. So you could expand and simplify and then see if it's factorable, but because it's in vertex form, I can actually just rearrange. Okay, so let's try that. Add 8 to both sides, divide both sides by 2. Okay, now here you gotta be very careful. You're gonna square root both sides. So x plus 3, yes, it could be 2 because 2 squared is 4, but x plus 3 could have also been negative 2 because negative 2 squared is 4 as well. So it's plus or minus 2, which means x is negative 3 plus or minus 2, which means x is either negative 5 when it's negative 3 minus 2 or negative 3 plus 2, which is negative 1. Okay, so same approach here. You can just perform inverse operations. I'll show you the other way too if you don't feel comfortable with this way. So divide both sides by 2, so negative 2, which gives you 8, square root. So it's plus or minus root 8. X equals 1 plus or minus, and root 8, we can simplify that. So it's 2 root 2 because root 8 is, well, 8 has a factor of 4. So yeah, 2 root 2. There we go. That's it. So I'm actually going to do C again. I'm going to do it the other way, just in case you didn't like it that way. So I'm going to expand and then factor. Perfect square trinomial. So 2x squared plus 12x plus 18 minus 8. Divide everything by 2 here. Factor, what multiplies a 5 and add to 6? 5 and 1. So x is negative 5 or x is equal to negative 1. Boom, same thing. Okay, so I would personally rearrange, but if you're not comfortable with that, then by all means expand and simplify and then factor. Now for D, you actually, if you expand and simplify, it's not factorable because I know what the roots are, and it's not going to be factorable. So after you expand and simplify, then you have to use a quadratic formula, and I'm done with the quadratic formula. I already did it 2 times for A and B, so I'm very reluctant to do it one more time. Okay, so one more thing from grade 10, just in case you forget. Some questions, you don't really care for what the roots are. You just care about the number of roots or the nature of the roots. Okay, so if that's the case, you want to find the discriminant. So 3 things can happen when you find the discriminant. It could be less than 0, greater than 0, or equal to 0. So if it's less than 0, you have 2 complex roots. Now, for our course, we don't really care for complex roots. So what you're most likely going to say is, yes, there are 2 complex roots, but you're more likely to say that if the discriminant is negative, there are no real roots. Okay, because real roots are what we're really interested in for this course. Okay, now if the discriminant is greater than 0, then you have 2 unique real roots. So you'll get 2 answers which are different from one another. Now if the discriminant is 0, you'll get a double root, which is just a fancy way of saying you'll get you'll get an answer and it's basically repeated. You get the same answer 2 times. So yeah, that's a double root. So one of these 3 things can happen. So how do I find out which of these 3? Well, we need to know what the discriminant is, which is b squared minus 4ac, the radicand basically of the quadratic formula. So the discriminant in this case, negative 4 squared minus 4ac. So this is, you know what, I can already tell this is positive. because positive plus positive, so you know what? We'll find it anyways, but I already knew what's going to happen. So anyways, discriminant is 72. So since the discriminant is greater than 0, therefore you have 2 unique real roots. I don't know what the answers are, but I'm going to get 2 answers which are different from one another, and they're going to be real numbers. Okay, so hopefully now you're comfortable with solving quadratic equations again, and you're comfortable using the discriminant.